All right, if you are starting in 12.2, go back and watch the 12.1 video real quick, unless you felt like you did really well yesterday and you have that down and you're confident in your work. But we're going to start with matrix multiplication, which is a little bit tougher, and you guys are going to do an activity tomorrow that actually deals with matrix multiplication. You'll probably do it both Thursday and Friday. We'll just kind of see how it goes. I do want you to try to do some of the multiplication by hand, especially on the activity, so keep that in mind. I ask you to show your work on that. And then even on tonight's homework, there's 8 questions. Try to do 4 of them by hand, 4 in the calculator, just to get that practice. There is a no calculator part of this test at the end of the chapter, so I just want to point that out early on. So we will want to know how to do it both ways. All right, we're going to start with scalar multiplication. This is a pretty straightforward idea. We're just going to multiply each element in the matrix by that scalar. So in other words, if we look at this first example here, it's very much like the distributive property. We're just going to multiply each of these by 3. So 3 times 1 is 3, 3 times -2 is -6, 3 times 4 is 12, and 3 times 6 is 18. And there we go. So kind of a simple type of multiplication there. We might also see one that has a negative out front, and we treat that just like we always have as a -1. It essentially just will flip the sign of everything inside there. So -4, 0, +2, and -7. And there we go. This scalar also works with bigger matrices. So here is a 3 by 3, right? Well, just a bigger distributive property. I'm not going to draw all the arrows this time, just maybe that first one there. But then we get +2, -2 times times 4, pardon me, is -8. -14, +18, -4, 2 times -2 times 0 is 0, -2 times 5 is -10, and -2 times 6 is -12. And there we go. All right, so yeah, nice and easy with scalar multiplication. Just look out for numbers or negatives in front of matrices. All right, so with scalar multiplication and kind of combining what I just talked about in the last video and what you were trying yesterday is solving matrix equations, right? We can make them a little bit more complicated. And again, these work just like algebraic equations. So let's clean up what we can here. So I think the first thing is we want to kind of scale this matrix by 3. Let me leave that 2x there. So we'll get 6, -3, 9, and 12. And then let's rewrite this one over here so we have everything all set up. Okay, there we go. And again, if at any point I do move too quickly, you can always pause the video, or if you need to see a problem the second time, you can restart it right from the beginning. But at this point, we're solving for x, and just like an equation, let me actually write it out here. If this was 2x plus 4 equals 8, I have to imagine all of you would say, well, let's subtract 4, and then after we do that, we'll divide by 2. And that's exactly what's going to happen here, except we're working with a whole matrix instead. We're going to subtract this matrix, let me get it out there, to the other side. So 6, -3, 9, and 12. All right, there we go. So these will cancel over there, right? Just like when we subtract 2 numbers from each side, they always cancel on the one side. Let me rewrite my 2x over here on the left, though. Can't forget about that. And then we're going to subtract these, right? So careful with your negatives here. So we'll start with 8 minus 6. So the top left one's 8 minus 6 is 2. 5 minus -3. This one right here, I'm worried going to get a few of us here, right? Those double negatives are always very tricky. So we just need to say, okay, well, 5 minus -3. And if you need to write that off to the side, 5 minus -3, you can see, yep, that is a double negative. So that is going to be 5 plus 3, which is 8. Then we get 11 minus 9, which is 2. And then we get 0 minus 12, which is going to be -12, right? 0 minus 12. Now, a lot of us would say divide by 2 here. But up above, I did not show you how to divide a matrix, although I will admit it can be done, right? You can just divide each term by 2. But I'm actually going to refer to it as multiplying by 1/2. We really haven't seen that much this year, and it can sometimes be useful, right? I did talk about how to multiply a number in above, so I figured, why not? Why not multiply by 1/2 here? Although, again, dividing by 2 will get you to the same place. Multiplying by 1/2 and dividing by 2 are the same thing. So let's cut everything in half, right? So we'll say 1, 4, 1, and -6. Or if you just cut it all in half or divide it all by 2, and there we go. There is that missing matrix that was, well, right here, right? That's where that matrix would go, and if we plug that matrix in there, it should make the entire equation true. All right, so there it is, scalar multiplication, how to use it in solving an example problem. And yeah, let's talk about what happens, though, when we try to multiply two matrices. All right, so this is going to be a little interesting, just because usually, and I'm going to fill those blanks in a second. We'll come down here and try our first example, though, first. So I want to set up a times b. So let's go ahead and write the a1 right here. I'm pretty much just rewriting these. And I'm just going to place it right next to b. All right, remember when we put two things right next to each other, it indicates multiplication. Now, a lot of guys will just want to go ahead and multiply each element times each element. So, for example, positive 2 times negative 1, 1 times 3, negative 3 times 0, 0 times 4, right? That's a very sort of common thing to think, just because that's what we did with addition and subtraction. But that's not actually the case, right? So what we're going to see is that we want to come up, let me draw a little, I'm going to label these. This is a 2 by 2, and this is a 2 by 2. Dimensions are going to become very important in this section. We want to come up with an element right here, right, in our answer matrix. Now, if you think about that element that I have circled, I don't know what number it is yet because I haven't done the problem, but that element is in row 1, column 1. Row 1, column 1. That's where that element is, okay? So when we think about it that way, I got to erase all this here. I'm not on notability, so it's a little different. So let me redraw that. When we think about that very first element up here, it's not just based off the 2 and the negative 1 over here. It can't be, right? Because sure, those numbers are in row 1 and column 1, but they don't make up the entire row 1 and the entire column 1. What makes up the entire row 1 and column 1 are these guys. Here's row 1. I can circle row 1 right there. And here's column 1 right here. Those numbers make up the first row and the first column of those two matrices we're trying to multiply. And those are the four numbers we're going to use to get our first number of this multiplication problem. So here's how we're going to do it. We are going to take 2 times negative 1. Right? Let me actually do a little work off to the side here. 2 times negative 1. And we are going to do 1 times 0. And we're going to add those together. And that will give us the first element of this thing, of this answer matrix. So here's what we're going to do. Let's see. 2 times negative 1 is negative 2. Plus 1 times 0 is 0. And that comes out to negative 2. And so sure enough, kind of oddly, I said you can't do 2 times negative 1 at the beginning, but it did come out to negative 2. It does come out to negative 2. Okay, so let's do this. Let's now talk about this number, right? Now, if you kind of take what we talked about in the last little part of the problem, that number is in row 1, column 2. Right? Row 1, column 2. So I'm still going to take row 1 right here. But this time I'm going to do the same thing with column 2. So here we go. And I'm not going to draw my arrows this time. What we're going to do is we're going to do 2 times 3, because that's the first number in each of those. So 2 times 3, plus 1 times 4. 1 times 4. Right? And we add those together. That is 6 and 4, which makes 10. So we get 10 right there. Nice. All right, let's get this number down here, which means it's in the second row, first column. So this time I am going to hop down to the second row, since I'm in the second row, and I'm going to reuse the first column this time, the negative 1 and the 0. So here we go, first number times first number. We're going to do negative 3 times negative 1. Then we're going to do 0 times 0, so plus 0 times 0, which will be positive 3 and 0, which makes positive 3, and there's our number. Okay, and if you've got the pattern down, you realize, okay, last number here is going to be the second row again, right? But this time the last column, the 3 and the 4. So again, first number times first number. Second number times second number. So negative 3 times 3. Negative 3 times positive 3. And then 0 times 4. And if we add those two together, we're going to get negative 9. And negative 9 and 0 will make negative 9. And there we go. All right, so yeah, it kind of worked out there for us. But that's just one example, and I'm certain that it's, tough to kind of process all that at once. So I think doing another example is worth it. But this time I want to do b times a. Now, we know that in mathematics, and if you see what I'm trying to prove here, I'm trying to prove that you can do multiplication in any order. And we know in normal mathematics, right, 2 times 3 is the same thing as 3 times 2. We can do multiplication in any order we want. Yesterday, we were able to do addition in any order we want to still get the same answer. But let's look down here and see, does that hold true with multiplication with matrices? So I want to do the same problem above, but I want to flip-flop it. So let's put the B matrix first and the A matrix second. All right, so I've got that all set up there. Now, again, I'm going to put the dimensions below. We'll talk about why I'm doing this. It'll pay off here in a moment. Okay, so 2 by 2 and a 2 by 2. Oh, by the way, didn't the answer, let's go back up real quick to the top one. The top one also came out to a 2 by 2, so I have to imagine this one will also come out to a 2 by 2. So we're going to take our first row and our first column. And this time I think I'll use a highlighter to make this. So we'll do -1 times 2, and then we'll do 3 times -3. So sort of that first number of the row times the first number of the column, second number of the row times the second number of the column. Let me do a little space out here. -1, let me get my pen actually. Hold on one second. -1 times 2 plus 3 times -3. And if we add those together, that's -2 and -9 make -11. Okay, well then we should automatically, after this first problem, notice something. That is not the same number we got out above. So either we made a mistake or maybe the order in which we multiply matters. And that's going to be weird because it doesn't with normal numbers. Let me go back over here. 2 times 3 and 3 times 2, but maybe it does with matrices. Well, let's see if this keeps working out. All right, I'm going to do the first row again times the second column. So again, I'm going to do -1 times 1 and 3 times 0. All right, so let's go over here. We'll do -1 times 1 plus 3 times 0, which comes out to -1. And there we go. So yeah, it looks like we're getting a different answer here. All right, we'll summarize this in a second, though, but let's finish this one off. All right, we're in the second row now. Let's do 0 and 4, and we'll start back with that first column again. 0 times 2 plus, we have here 4 times -3. Okay, so 0 times 2, 4, -3. And it looks like we're just going to get a -12 there. And then last number, we'll do 0 and 4 again because we're still in row 2. But this time we're over in the second column. And we'll do 0 times 1. And we'll do 4 times 0, which I think it's all going to come out to 0 there. So there we go. So there's our answer this time. And yeah, so if we look at the two answers from above and below, they did not come out to the same. So the order in which we multiply matters, right? In other words, multiplication is not commutative here. So yesterday we found it to be commutative. Addition and subtraction work the same way that normal numbers do, but multiplication does not work the same way as normal numbers do. So it does matter which order you multiply them in. So just the reason I bring it up is be careful on a test. If I give you 5 matrices and I say, okay, go ahead and multiply matrix B times matrix C, make sure you do B times C, not C times B, right? Because otherwise, if you flip-flop that order, you're going to get the wrong answer. So very careful on that one. All right, so there's our first introduction here. So multiply each element of a row in the first matrix by the corresponding elements of a column in the second matrix, right? So rows times columns. And that's our rule of thumb. You will always, always, always do rows in the first one and columns in the second one. Okay, never switch that up. Don't do columns in the first one and rows in the second matrix. Rows in the first one, columns in the second. All right, let's look at another example here on the next page, though. All right, so over here, we'll fill in these blanks in a second, but I've got some differences, and I'm also going to show you how to do this in the calculator. You'll see down in the bottom also. We'll check that out. I told you we would see that. But let's look at what happens if the dimensions are not the same. So if we think back to yesterday when we were adding and subtracting matrices, the dimensions absolutely had to be the same, right? Because we're just adding element plus element. And if there aren't enough elements in one matrix, then you can't add it to the other matrix. They just don't match up. But does that work for multiplication? Well, before we fill in the blanks, let's look down here real quick. So let's imagine we kind of stick with our rule of thumb from above. Row times column. Well, if you look at this, they both have two numbers in them, so we could do 4 times 1 and 0 times 0. Like, it seems like this might work out. And in fact, it does work out. We can multiply matrices of different sizes. Speaking of sizes, though, before we jump into this problem, let's go ahead and list the size of this matrix. Okay, so the first matrix over here is what do we have? 3 row, so 1, 2, 3, and a 2 column, so a 3 row and 2 column matrix. This is a 3 by 2. Let me clean that up real quick. And then over here, we've got a 2 row by 4 column matrix. And I'm going to talk quite a bit about these dimensions at the end here, but let's do this problem here. So we are going to start off, and I really don't know, how big this answer is going to be, just because I'm going to draw a pretty big bracket, though. We can shrink it if we need to in a minute. But let's just start with the first row and first column. And I always love this example because it really kind of spells out, the entire process behind matrix multiplication. Okay. Now I'm going to show the first couple steps here, my work, and then I'm going to start skipping a little bit of work because I didn't leave us a ton of space here. Plus, I want us to start, trying to grind these out a little quicker with some mental math. It's always a good thing to practice. All right, so we'll start here by just doing the typical. We've got our first row. Let's take the first number 4 and multiply it by the first number 1. So we'll do 4 times 1. Let's do that. 4 times 1, plus. And then we'll get our second set of numbers, 0 times 0, right? Always first number times first number, second number times second number. And that's going to come out to 4, and there we go. We'll put that in our first row, first column slot. And then we're just going to keep going with the first row, and we're just going to work our way across the columns here. So here we go, 2 and negative 2. So we'll use our first row again. We'll do 4 times 2, and then we'll do 0 times negative 2. All right, so 4 times, let me get my pen here, 4 times 2 plus 0 times negative 2. And, 4 times 2 is 8, 0 times negative 2 is 0, so that's going to come out to 8, so there we go. All right, let's work our way to the next column. So it looks like we should have 4 numbers across the top because we've got 4 numbers, or 4 columns in the second matrix. All right, so we'll do 4 times 6, and again, 0 times 4. So 4 times 6, 4, oops, let me get my pen again. I keep using the highlighter on accident. 4 times 6 plus 0 times 4. All right, that's 24 and 0, which makes 24. Okay, there we go. All right, looks like this is going to be our last one here of at least this row. And now you might actually start to, see the answer size here because, well, we've got 2 more rows to go in the first matrix. And so we've got a bit more work to do here. All right, so let's get this last one done, though, right? We'll go, 4 times 5 and 0 times 6. So 4 times 5 plus 0 times 6. That's 20 and 0, which makes 20, and there we go. And that should be the end of that matrix there. We'll close that off because we've finished the first row. We've run out of columns. We can't go any further. But again, we've got 2 more rows. So what we're going to do is we're going to come down to this second row. There's negative 2 in this 6, and we're going to work our way across each column again, right? We've got a lot of work ahead of us on this one. So what seemed like maybe not such a big problem turned out to be pretty big. Now, this is where I'm going to stop highlighting a little bit, and I might jot this work down. I've got enough to do maybe the work for 1 more row, and then we're going to see if we can do our third row without any work. So first row, first column here we go. Negative 2 times 1, negative 2 times 1, plus 6 times 0. All right, and that'll come out to negative 2 when you simplify that. All right, now second row times second column. So we got negative 2 times 2 plus 6 times negative 2. All right, this is one of the first problems. We haven't had a 0 in it yet, so we got to make sure we get this number right here. So that's negative 4 and negative 12, which would make negative 16. So there we go. All right, second row, third column. Right, we got our third column, our 6 and our 4. So we got negative 2 times a 6 plus 6 times 4. All right, so let's see. Negative 12 and positive 24 should make positive 12. So we get positive 12 right there. And then last but not least, we've got our fourth row here of 5 and 6. So let's do negative 2 times 5, negative 2 times 5, plus 6 times 6. So that's what? Negative 10 and 36, which makes 26. So 26. All right, there we go. So we got that row done. We've got one more to go, and let's see if we can do this one kind of in our head here. So we've got our third and final row, all right here. And we're going to start our third final row. We're going to go right back to the first column. We're just going to work our way across the columns again with this third row. So 3 times 1 is 3. 4 times 0 is 0. And 3 plus 0 makes 3. All right, now onto the second column. 3 times 2 is 6. 4 times negative 2 is negative 8. And 6 and negative 8 make negative 2. All right. 3 times 6 is 18. 4 times 4 is 16. And 18 and 16 should make 34. So 34 right there. And then 3 times 5 is 15. And 4 times 6 is 24. And 15 and 24 should make 39. All right, but there we go. Pretty cool. All right, so let's do a couple things here. I'm going to, and if you need this work, you should pause now. I'm going to erase this work real quick. You on Notability can probably move it off to the side if you have it there or something like that. Probably want to keep it with your in your notes. But I want to talk about the dimension, the dimension of this answer matrix that we have here. This is a, let's see, 1, 2, 3, a 3 by 4 matrix. Now, this is such an interesting dimension because if you look at the original dimensions of the matrices, you can see a 3 and a 4 in there. You can also see that the two middle numbers, a 2 and a 2, match up. Now, that 2 and a 2 is kind of interesting because that means there are 2 columns in the first one and 2 rows in the second one. And the only reason this multiplication problem worked out is because, let's just go back to the first row and first column, the very first step we did, is there was 2 numbers in each of them. That's why this problem worked. Right? Here's the idea. Every time you set up a multiplication problem, if these match, so if these match, you can do the multiplication problem, right? They have to, in fact. So if you had a mismatch there, then there just wouldn't be enough numbers in each row and each column to be able to, do this process. And then even furthermore, it's kind of interesting, these 2 numbers, the end, are your answer size. So you actually know how big your matrix is going to be, right, when you start the problem. All right, so it's kind of an interesting way to do it. The dimensions of the matrix came out to a 3 by 4. And so we know we can tell it from the beginning just based off the original ones. So pretty cool. All right, so here's what I want you to do. I want you to pause this. We'll fill in the blanks in a second, but pause the video. Try this next one on your own. See what happens here. All right, so hopefully you tried it here on your own, and you found out that, well, first we should probably label the dimensions because we can tell a lot from those dimensions, a 2 by 2, 2 row by 2 column, and then this one has a 3 row by 2 column. And then we notice immediately, these don't match up, right? Now, the answer would be a 2 by 2 if they did, but they don't. And even if you tried to start the problem, you took your first row and your first column, you'd realize there are only 2 numbers in the first row, but 3 numbers in the first column. How are you supposed to do the calculation like we've been doing? So yeah, cannot multiply, right? Cannot multiply, and that's our answer for this one. So at least we see one that doesn't work for us. So to fill out these blanks at the top, you can only multiply matrices if the number of columns in the first matrix, which is the second number in the dimension, is equal to the number of rows in the second matrix, in matrix B. And then, of course, the answer is always the rows from column A and the columns from B. There we go. All right, now, again, all of this, including addition, subtraction, but especially multiplication, since multiplication is kind of tough, can be done in the calculator. And so I want to try these two with you. In fact, I'll try number one, and then I'll let you guys do number two. They both can be multiplied. But the reason I want to do number one is the problem that we did right here. So I just actually want to use it as an opportunity for us to check our work on this stuff above. All right, so here's what we're going to do. To add it, or to multiply and or add or subtract, although let me put a disclaimer on addition and subtraction. I personally think you can do addition and subtraction of matrices faster by hand than you can in the calculator. By the time you enter all the numbers in the calculator, I'm sure you would have finished just the addition of all the numbers. So anyway, go to second matrix, right, that second x to the negative 1 key, and we'll go over to edit. All right, so let's do that together here. We'll go to second matrix and we'll go over to edit. Now, you realize that this is probably the first time we're going to use matrix A and matrix B. In other words, we're going to use two matrices in a problem. So I'm going to go and choose matrix A first. So go ahead and hit enter on matrix A. Make sure you're in the edit menu. And what was our matrix size? Well, I guess we could do it down. We could look either down here or up there. The first size is a 3x2. The second one's a 2x4. So let's make matrix A the 3x2. So switch your dimensions to 3x2 and go ahead and enter these numbers 4, 0, -2, 6, 3, and 4. If you need to pause, go ahead and pause. Once we do that, we're going to second quit. We should be back at the home screen. Actually, let's add that step in there. I noticed I didn't put a blank where we can, let me erase that arrow. Let's add it right here. We'll add a step, second quit. All right, you always want to quit when you're done editing. All right, now back into second matrix we go. We're going to edit our second matrix. All right, so back into second matrix and back over to edit. But this time in second matrix under edit, I want you to go to matrix B. Right, we need to enter a new matrix, and let's make matrix B this 2x4. So switch your dimensions to a 2 and a 4, and go ahead and enter these numbers. Again, if you need to pause, go ahead and pause. But once we get them entered in, we will then again hit second quit, and we should be back at the same, or the home menu. Go back into second matrix for the last time. Okay, since we're done editing. So go back into second matrix, and then on the names menu, just go ahead and hit enter on matrix A. Now you have an option here. You can hit the multiplication sign if you want, but if you just go back into second matrix and you choose matrix B, whenever two things are next to each other in math, it always indicates multiplication, and your calculator knows that. So whether you hit the multiplication sign here or not, if you go back into second matrix and you choose matrix B under the names menu, and then you hit enter, you should see the following. Oh, let's fill that out. Choose matrix A, and then go back into second matrix and choose matrix B. And I got 4, 8, 24, 20, -2, -16, 12, 26, 3, -2, 34, and 39, which was our 3x4. And just so we have a moment to check, is that the same answer we got above? And certainly it is. So it looks like we did all the math correctly by hand, and now we've confirmed that with the calculator. So much faster with the calculator, but again, I do want you to at least know both ways. So I'll test you on both ways. And then on tomorrow's activity, which is you guys building kind of a company, essentially, and looking at data within that company. And I had told you guys earlier in this chapter that matrices are a great way of organizing a lot of information. So I'm going to throw a lot of information at you all tomorrow. The hint for that activity is that you are going to use a lot of multiplication to get through it. I would prefer you to try to do as much multiplication by hand tomorrow as you can. I do say show your work on that activity, as I mentioned at the beginning of this, so make sure you do that. Also, tonight's homework, there are 8 questions. I would like you to do 4 of them by hand and then 4 in the calculator, just to kind of test yourself both ways and make sure you know how to do it both ways. But do email me if you have questions on the activity tomorrow. It's a fun one, but it is a challenging one, and we'll see what happens on Friday. If we need more time on it, we'll take it. If not, we'll go from there. Just turn it into the folder once you're done. Show your work with your partner, and hopefully you have fun with it. Otherwise, I'll see you guys soon.